What happens when we find the sum of a rational number and an irrational number? The sum of 5/3 and √3 is an irrational quantity. So can we conclude that the sum of a rational number and an irrational number is always irrational? Let's assume the opposite, that the sum of a rational and an irrational number is also rational. We can write our rational number as a ratio of two integers, a and b, and add an irrational number, x. Then according to our assumption, the answer is also rational, so we can write this as a ratio of integers m and n. We manipulate this equation by subtracting a over b on both sides and get x equals m over n minus a over b. Then simplify the fraction on the right-hand side by writing it as one fraction with the same denominator, nb. But we have now formed a fraction that has an expression that will be an integer in the numerator and an expression that will be an integer in the denominator, which means x cannot be an irrational number after all. It can be written as the ratio of two integers, which is the definition of a rational number. So we've contradicted our original assumptions and can conclude the sum of a rational number and an irrational number is always irrational. We've used a proof by contradiction to show this result. We can work in exactly the same way to prove that the difference of a rational number and an irrational number is also always irrational.